over 5 times f, let's change back to black, f minus 32. Oh, I forgot a huge thing. I just realized I wasn't recording, so I got to go back real quick. But we'll have 9 over 5 times 5 over 9 times that f minus 32. Well, on the left-hand side, I'm still stuck with 9 over 5 times c. 9 over 5 times 5 over 9, that just equals 1. And that's going to give me f minus 32 on that side. Now all I have to do is add 32 to both sides, and we're going to have Fahrenheit equals 9 divided by our Celsius plus 32, and that is solved. All right, so once again, simple one. You should all be able to do that. This one, all the people that aren't paying attention right now are just going, whatever, are going to get this one wrong. The hardest one, though, is this one. This one employs a whole bunch of stuff all in one problem. That is because r sub 2 is trapped on that bottom right-hand corner of a fraction. Now, for people that don't study their notes and aren't paying attention, what they're going to try to do is actually solve for r sub 2 without trying to get rid of their fractions first. You need to get rid of all of your fractions first. It is the only method that's going to work successfully. Any other method is going to require way too much work and stuff we're not even talking about. So the first thing I need to do is get rid of all of the fractions since we have a whole bunch of variables in the denominators. To get rid of all of those fractions, we're going to multiply by our lowest common denominator, our LCD. Well, in this case, our LCD is going to be all of our denominators multiplied together. So that's going to be r times r sub 1 times r sub 2. As soon as we have a lowest common denominator, we're going to multiply that by everything. So let me set that up. We'll have r times r sub 1 times r sub 2. And we're going to multiply that by everything. So that's 1 over r equals 1 over r sub 1 plus 1 over r sub 2. And we are going to distribute that r sub 1, r sub 2 to all three of those terms. So that's going to look like this. Let's draw our arrow. So that's going to give me r sub 1, r sub 2, there's too many r's in this one, all over r, is going to equal r sub 1, r sub 2, all over r sub 1, plus r sub 1, r sub 2, all over r sub 2. Well, lots of stuff's going to cancel out. That will get rid of our denominator. So we will have r divided by r, and the first one will cancel out. R sub 1 and r sub 1 will cancel out in the next one. And finally, r sub 2 and r sub 2 will cancel out in that one. That will leave me with no more fractions. But it does also leave me with 2 r sub 2's. I need to have just one r sub 2. I need to have it saying r sub 2 equals something. So this is going to be very similar to this problem where I factor something out to turn it into 1. That's the only way to turn two things into 1, which means that I need to have both of my r sub 2's on one side. So I'm going to subtract that r sub 2 on the right-hand side from both sides to give me r sub 1 times r sub 2 minus r times r sub 2 equals r sub 1. Now I have both of my r sub 2's on the same side, so that means I can factor it out front. And so we're going to have r sub 2 times quantity r sub 1 minus r equals r sub 1. The last thing I need to do is divide both sides by that quantity r sub 1 minus r. Divide this side by quantity r sub 1 minus r. And that's going to leave with r sub 2 equals r sub 1 all over r sub 1 minus r. And I'm happy to be done with that problem because there's too many r's. Especially doing it for 2 classes. It's too many times saying r. All right, what questions do we have from this one? This is about as hard as they get. This is the one that I put on the test and someone gets a 1 out of 4 because they didn't quite understand what they're doing. Because you A, have to know how to get rid of fractions. B, you have to recognize how to factor out numbers. And then you have to realize what to do after that. Yeah, Tasha.
Could you not start from, so before like where the blue circles are? Yeah, one of them, that one. Could you not take out R out of the right equation and then go from there? Or do you have to like...
How would I get it out of here, I guess?
Well, couldn't you do, like, take R out and then do what you did in the same
Oh,
way?
take this R out here?
Yeah, and then do R2 plus R1 in parentheses.
We could. The problem is now I have R sub 2 on both sides still.
Okay.
I need to get it all by itself.
Okay.
All right, so you're going to create more work later on for yourself.
Okay.
It's definitely possible. If I was solving for R, that's exactly what I would do. Because then we could divide it. But then I'd have two R sub 2s.
Okay.
My whole goal is to just have one R sub 2. Are other questions on any one of these 4? Okay, here are 3 equations that you should know. We're going to very briefly go over them and kind of how to use them. Most of these problems in the homework, you can kind of figure out what formulas you need or what's going on. So the first one is simple interest. And that says I equals PRT. Well, I is just your interest. So if you buy socks and you pay 5% on it, it turns out you bought socks for $3 and you pay 4 cents for tax. This would be your 4 cents for your tax. This would come up with basically your tax.
What just happened?
This is just the portion that's interest or your percentage. Your interest is going to equal what's called your principal. Your principal is your initial. It's your initial cost, payment, what have you, cost, investment, payment. It is that initial amount, R is going to be your rate. It's going to be in a percentage most likely, or a decimal. And finally, T is your time, and that's in years. So if you do your initial cost times your rate times your time, that's how much interest you'll gain. That's how much tax you pay. That's how much, that's that decimal portion of it. All right, the next one is S equals P plus PRT. Well, that's your, S is typically your sum. It's your total amount. It is your total cost. It is your sum. It is everything, all added together. Your sum is going to equal your principal. Remember, that's your initial amount. Plus your interest. But interest is a filler word. What this could be is your socks. Your socks cost $4 plus 4 cents. Your total cost would be $4.04. When you walk into a store and you buy something, you can't have that amount in your wallet. You have to have more than that. When you go and buy a new car, that car sticker price may say $17,000, but you need a lot more money to purchase that because you have sales tax, you have to register it, you have to do all this other stuff. So it's probably going to come out to like $18,000 something. This would be your $18,000. This P would be your sticker price. This R would be your tax. Time would not matter on a car. That's more for investments. All right, the other one is your temperature. That is Celsius and Fahrenheit. Yeah, Emma?
So you have 2 initial costs?
No?
Yeah, they're 2 P's.
Yeah.
But one of them's with interest.
Well, one is your initial amount.
Yeah.
One is how much the interest is or how much the tax is.
But the interest includes the initial cost.
That's how you calculate your
Yeah, but yeah.
Yeah. Yes. So yes, there are 2 P's in it. Yes. All right. Our next one is Celsius and Fahrenheit, and the last one is uniform motion. That is distance equals rate times time. Your speed over how long you do it. If you run 6 miles per hour for an hour, you run 6 miles. Okay. Let's talk about Gini. Jeannie's buying a 1982 DeLorean DMC 12 for a total cost of $18,966, including sales tax. That means she hands that money over and she has the car. That is her total cost. If the sales tax rate is 9%, then what amount of tax did she actually pay? Well, this is going to be like the interest type problem, where we have a total amount is going to equal the initial cost of the car plus P times R. Here's the thing. In this formula, I am not going to worry about the time. There is no time. She's not purchasing it on a payment plan. She's purchasing it up front, so time isn't going to matter. All I need to have is my sum. That is my total cost. Well, the total cost of the car was $18,966. I don't know the sticker price on the car, so that's P plus P. I do know the interest rate is 9%, but you aren't going to put a 9 there. You're going to put 0.09. You're always going to change your percents to decimals when you're working with equations. Now we have to solve for P, but there's two of them. This would be the time that you're going to factor out a P. You're going to factor out a P so that we just have one of them and we can actually solve it. So that's going to give us 18,966 equals P times 1 plus 0.09. One step further, that would be 18,966 times our principal times 1.09. Now all we have to do is divide both sides by 1.09. And for all those friendly people pulling out their calculators, can someone give me what that equals? 17,400? Do we get different answers? I don't think 9,000 is going to be right. What'd you get? Okay, there's two people getting 17,400. I bet you that's it.
She's on it.
All right, is that my answer, though? No, that is the sticker price of the car. If I know the sticker price of the car and the amount I paid, how I'm going to come up with how much tax I actually paid? Yeah. We can subtract. We can subtract our total minus 966, and we're going to subtract away the sticker price, and that's how much our tax was. And how much is our tax? 1,509.
1566.
Wow.
Whoa.
1,000. Just for the sake of this being a math class, there is another way to get that total, and that is just our interest. Insert it into the interest portion of it, where your interest would equal P times R. In this case, our interest is our tax. So P times R, remember, we're not dealing with our time because we don't have a time frame on this one. So our principal was 17,400 times our rate, which was 0.09. If you would do that, you'd actually come up with 1566 as well. More often than not, you're just going to use this one. It's just quicker. It just makes a little more sense. So interest isn't always interest. It's kind of this overarching formula. Overarching. Yeah, anyway. It's a formula that just covers a whole bunch of bases depending on what you're talking about. So in this case, it really wasn't interest. It was tax. Your interest was actually a tax. All right, the next one is more of a fan service type problem. It's the one that most people can do after we do it. It's usually a pretty good one to put on a test that at least people get a word problem correct. So it says in 1974, Chinese workers unearthed 3 pits with life-size sculptures of warriors created to guard the tomb of the emperor. The largest rectangular pit has a length that is 40 yards longer than 3 times the width. Its perimeter is 640 yards. So I really don't care that there was 3 pits. The only thing we're focusing on is that largest rectangular pit. That's all we care about. So let's go ahead and draw a rectangular pit. A rectangle has two sides. It's got a length. Well, it's got four sides, but we narrow them down to a length and a width. I actually want the width up here because the length is longer than this one. All right, it says that the length is 40 yards longer than 3 times the width. So I'm going to leave width as just W, and I'm going to rewrite my length. It says your length is 40 yards longer than 3 times the width. So if I multiplied the width by 3 and then added 40, I would get my length out. Okay, then they say the perimeter equals 640. So just remember, a perimeter of a square or rectangle is going to equal length plus width plus width. In other words, 2 lengths plus 2 widths equals our perimeter. Well, it goes on to say that our perimeter is 640 yards. So we're going to have 640 equals 2 times my length, which is 3W plus 40 plus 2W. And now we just got to work our way down to solve for W. So going down, we'll have 640 equals 6W plus 80 plus 2W. Subtract 80 from both sides, and we'll have 560 equals 8W. Divide both sides by 8, and we should come up with W equals 70. So my width equals 70, and my length would equal 3 times 70 plus 40, which is going to equal 250. And I should attach, since they did give me yards, I should put yards on both of them. Jacob, did you have something? Sorry. You sure? Was it the yards thing? Okay, yeah. They should have yards because they gave us their yards. All right, that's all I have for you today. Make sure you understand these word problems. Try your best on them, because on Monday we'll have harder word problems. We're going to have mixing problems. We're going to have distance problems. We're basically going to come up with anything that you need, like a chart, to solve. And I know for a fact you did all of this in Algebra 2. So that's why we kind of pushed through this section.